Hello students, good afternoon everyone. This is Ram Saurav, your maths faculty. I welcome you all to Turito live classes. Children, today we are going to discuss about some other topic, children. So let us see what are those topics. Learn by one. Children, today we are going to learn the few concepts. Let us see what is those concepts, children. The first topic is what? The revision of what? Laws of exponents. Children, you already learned the laws of exponents, isn't it? So what is the exponential form and what is the laws of exponents? Like laws of exponents mean here like formulas. So formulas which are involved in the exponents, we can call them into what? Generally the laws of exponent. Are you getting my point? Here laws of exponents what? Just generally you can say a formulas which are related to what? Exponents. Is it clear? And second one is what? Introduction of logarithm. Children, this topic is new for you. Okay. I think might be some students of knowing this topic, but I can say this is a new topic for you. And we are going to discuss laws of logarithm. Like formulas related to logarithms, we can say here laws of logarithm. Clear, children? So first topic is the revision of laws of exponents, like exponential form and some formulas we are going to discuss. And the second topic is introduction of logarithm. And the next topic we are going to discuss the laws of logarithm. Okay, like which formulas we are involving when you are using the logarithm. So that is called what? Laws of logarithm. Clear, children, regarding these three topics? Now children, let us say one by one what is the laws of exponents and introduction of logarithm and laws of logarithm. Clear? Now children, exponential form. Children, I am taking the, you take a positive integer a. Okay, suppose this a, I am multiplying itself n times. Like multiplying itself means like a into a into a into a into so on. So this a is what? I am multiplying itself n times, children. Like a is repeating what? N times. And this all n a's are multiplying itself. So it is called what? Generally expanded form. The same multiplication if you are writing by using exponents. Like how we can write this? This is, we can say a power n. So this is called what? Exponential form. Are you getting my point, children? This is called what? Exponential form. That means the same product, like the bigger multiplication we are writing shortly. That short notation we can say what, children? Exponential form here. Okay. Suppose I am writing here a to the power of n means here a is called what, children? Generally a is called base. Okay. So a is called what? The base of a to the power of the exponent, exponential form, and n is called what, children, here? Here a is called what? Exponent. Sorry, a is called what? Base, and n is called what? We can say exponent, or we can say power, or we can say what, children? Index also. You can call index, or you can say power, or you can say what, children? Exponent also. Okay. Here a is called directly base, the number which you are multiplying continuously, like n times or 6 times or 10 times, 20 times, whatever it. See, I am writing 3 into 3 into 3 into 3. So it is what? Expanding form. So this I want to write by using the exponential form. So how we are at, children? 1, 2, 3, 4. So here 3 is repeating how many times? 4 times. So I can write as 3 to the power of 4. Okay. Here what is the base? Base is 3. And what is the exponent here? Here 4 is the exponent. Here base is what? 3 and 4 is the exponent. Sorry. So here exponent is a 4. Clear, children? Any doubts regarding this base and exponent identifying? Children, it is very simple. Suppose if I am writing 2 to the power of 5. Here what is the base? 2 is the base. Okay. Here 2 is called what? Base of exponential form. This 2 power 5. And 5 is called what here? Exponent. Clear, children? Here 2 is the base and 5 is the exponent. and this form, otherwise this notation, we can call what? Exponential form. This form we can say generally exponential form, otherwise we can say exponential notation also. Okay. See children, any doubts regarding this basic information, like what is the exponent, what is the base, and what is the expanded form, and what is the exponential form? It's a very simple children, you can easily understand. Okay. Now children, loss of exponents. The first one is what children? Zero exponent. Here zero exponent means if you take any number children, if you apply the exponent is what? Something 0. So that gives the answer is equal to what? 1. But here the condition is what? The base should be a non-zero number. Okay, the base should be what? A non-zero number. You cannot take the base is 0. And this 0 exponent we can apply only for non-zero numbers. Okay, you can take anything. You can take what? 1 by 2 whole to the power of 0. You can write answer is 1. Or you can to write something 3 by 4 whole to the power of 0 also. The answer is 1. Okay. But for the 0, like 0 to the power of 0, this is what? Not equal to 1. So for this number, we cannot apply the 0 exponent. Okay. 0 exponent we cannot apply for the what? A 0 number. Like a to the power of 0 is equal to 1. Here a is what? A non-zero number, means a should not be equal to 0. So that is the condition children. Okay. So that is what actually a 0 exponent. Okay. Next one, negative exponent. So negative exponent means what children? If I am taking a to the power of minus m. So here minus m is what children? It is a negative number, like negative integer. So in that case, a to the power of minus m, we can write 1 by a to the power of m. Okay. 1 by a to the power of m, again same, here a should not be equal to 0. I'll give an example children, just listen here. I am taking 3 to the power of minus 4. How we can write 3 to the power of minus 4? We can write as 1 by 3 to the power of plus 4, isn't it? So 3 power minus 4 we can write as 1 by 3 to the power of plus 4. So whenever you get the negative exponent, so we will get the what? The base should be in the reciprocal and the exponent will be converted as a positive. So 3 power minus 4 we can write as 1 by 3 to the power of plus 4. So it is called what? A negative exponent. Next one is what? Exponent of 1. So what is the exponent of 1? It's very simple. If you am taking one number is 1, 8 to the power of 8. So 1 is equal to what? Answer is 8. You can write 20 whole to the power of 1. We can write answer is 20. You can write 3 to the power of 1. We can write the answer is 3. So any number whole to the power of 1 it gives the same, like 0 to the power of 1, it is 0. Because 0 is what? Multiplying itself only one time. Okay. You can write 100 to the power of 1 also. What is the answer children? Here it is 1 only. Because exponent value is 1. So we will get the answer is 1. Like same number. Because the number is what? You are multiplying only one time. So it gives the what? Repetition is 1. If I write something exponent is 2, it is repetition is 2. If I am writing 10 to the power of 2, what does it mean children? It is 10 into 10. Okay. So 10 into 10 is nothing but what? This is 100. So 10 square value 100. So exponent of 1 is what? A to the power of 1, where answer is what? Same, like a power 1 is equal to a. So that is the what? Exponent of 1. Next one children, inverse. So what is the inverse? Very simple. 3 to the power of minus 1. We can write directly 1 by 3. You can write as 20 whole to the power of minus 1. You can write as 1 by 20. Okay. Or you can write as something 100 whole to the power of minus 1. So we can write as 1 by directly 100. You can write as 5 whole to the power of minus 1. So we can write as 1 by 5. So it is called what? Inverse exponent. Are you getting my point children? The exponent value is minus 1. So we can call it is inverse exponent. So the number will come directly in denominator. Okay. So that is what? A negative, sorry. What is exponent? Inverse exponent that is. Okay. Children, what is the next property? What is the next law? Product law. So what is the product law? It's a very simple. A to the power of m into a to the power of n. Like when the bases are equal and you are doing what? A multiplication. So at that time what happens, children? The exponents are adding. So a to the power of, we can write as m plus n. So it is called what? A product law. So multiplication means you will get the addition. So this is multiplication. Here you will get the addition like plus. A to the power of m into a to the power of n, we can write as a to the power of m plus n. So that is what? Under multiplication. Okay. So this gives the what? A to the power of m plus n. So that is what? Product law. You can take one example, children. I am writing 2 to the power of 5, I am writing 2 to the power of 4. So what is the answer? First one, just look at this. Can I say bases are equal here? Yes, bases are same. Then you are doing what? Product 2. So what is the answer? 2 to the power of, will get 5 plus 4. So 5 plus 4 value equal to how much? 9. So the answer is equal to how much? 2 to the power of 9 is the answer. Okay. So 2 to the power of 5 into 2 to the power of 4 is equal to 2 power 5 plus 4. So we can say answer is what? A 2 to the power of 9 is the answer. Clear, children? So it is what? A product law. And next one, children, quotient law. So what is the meaning of quotient law? Quotient means what? Like division. I told you already. Okay. In the rational numbers, I told you quotient means here is a division, like rational form. So I am taking a to the power of m by a to the power of n. So we are going to get a to the power of m minus n. Division means what? Subtraction. Here what is the condition? If m is greater than n and 1 by a to the power of n minus m, here m is what? Less than n. So that is the condition. Okay. Clear, children, this formula? Now the same thing we will apply for some numbers also. I am writing suppose 3 to the power of 5 by 3 to the power of 2. See, base are same and division. So we can say directly 3 to the power of what, children? This is 5 minus 2. This is what? A 3 to the power of 3. So this is what? Under division. So when the base are like under division, we will get the what? Subtraction. So division means what here? We got subtraction. See, it is minus. So multiplication means we will get the addition. Like division means exponents are subtracted. Multiplication means exponents are added. Clear, children? Fine. Next one, power of power. If a to the power of m and whole to the power of n. So it is what? A power of, again one more power. So a to the power of m whole to the power of n. So we can write as a to the power of m into n. So this both powers are what? Getting multiplied. Okay. So m is the one exponent, you can take n also one exponent. So both exponents are getting multiplied. That is called what? A power of power. Children, you can take one example. 2 to the power of 3 and whole to the power of 5. So 2 power 3 and whole power 5. Tell me, children, how we can apply this formula here? So here both are exponent. So we can write 2 to the power of 3 into 5. So we can write as 2 to the power of 15 is the answer. Because both the exponents are getting multiplied. Okay. So this is what? A 3 into 5. So 3 into 5, it is 15. So answer is what? 2 to the power of 15 is the answer. Clear, children? This power of power law is very simple. Next one, product of product. Sorry, power of product. This is very simple, children. A to the power of, okay, we'll do one thing. A into b whole to the power of m. So we can write as a to the power of m into b to the power of m. It is under multiplication. The same formula we can apply for division also. We can write as a by b whole to the power of m. So we can write as a to the power of m by and b to the power of m. Okay. So this is same formula under multiplication. It is under division. Here power is what? Getting distributed for the both the numbers. Here power is distribution for a and power is distribution for b. And here also a and here also b. So a power m by b power m. Here a power m into b to the power of m. That is called what? A power distribution. Under multiplication and same thing under division also. Clear, children? Any doubts? Okay. Children, let us apply this formula. Okay, one more formula, children, I wanted to tell you. It's very important. If a to the power of m is equal to what, children? A to the power of n. Okay. If the two bases are equal, so directly we can say exponents are equal. So directly we can say m is equal to n. I'll give an example. 2 to the power of 3 is equal to what? Something 2 to the power of x. So what is the x value here? Directly 3, because here bases are same under equality. So directly we can say x is equal to 3 is the answer. Okay. And next one. If a to the power of m is equal to something b to the power of m. In the second case, what happens, children? Exponents are equal. If a to the power of m is equal to what? B to the power of m. So directly what we can say? Bases are same. So a is equal to b. Exponents are same. Here m is equal to what? Here m. So m is equal to m means directly we can say a is equal to b. Exponents are equal means directly we can say bases are same. The bases are same means we can say exponents are equal. In the first case, bases are equal, therefore exponents are equal. In the second case, exponents are equal, therefore bases are equal. Clear, children? Any doubts regarding this all formulas, laws of exponents? Children, there are very, very important formulas. So try to remember and try to practice, okay? Now, children, see one examples. Find the value of 2 to the power of 1. Children, what is the 2 to the power of 1 value? It is 2. Okay. And 4.73 whole to the power of 0. Can I say answer is 1 here? Here we are applying the word 0. Like 0 exponent we are applying here, isn't it? So the answer is equal to 1. Okay, answer is equal to what? 1. Next, 0 whole to the power of 3. So what we get, children? Answer is 0 only. Okay. Next one is what? Minus 1 whole to the power of 4. That means minus 1 into minus 1 into minus 1 into minus 1. So minus into minus plus and plus into minus minus, again minus into minus plus. So 1 time 1, again 1 1 is 1 1 is 1. So answer is equal to 1 only. Okay. Next one, 0.25 whole to the power of, what is that? Minus 1. So 0.25 whole to the power of minus 1. So this we can write as 1 by 0.25. Okay. And how we can write again 0.25, children? We can write as 25 by 100. Are you getting my point? So this is 25 by 100. So this will be what? A reciprocal. We'll get 100 by what? A 25. So cancel. This is 25 ones and 25 fours. So answer is equal to 4 is the answer. Okay. Children, the same way you find the answer for this question, question number 6, and you can find the answer for question number 7. So there you can apply the same power distribution formula under division. Here also power distribution formula under division. Clear, children? Once look at the question. Any doubts? Questions are very simple, children. Try to practice. Okay. I have just given the basis questions. Next, laws of exponents. We'll apply here some question. Express 10, 100, 1000, 10,000 and something. So how we can write the exponential form, children? We need to use the laws of exponents. So how we can write 10? So 10 we can write as 10 to the power of 1. 100 we can write as 10 square. And 1000 we can write as 10 to the power of 3. And 10 to the power of 4. And this is 10 to the power of 5 and so on. Okay. So the complete bigger number I am writing as a very shortly. So that is what? 10 to the power of 1, 10 to the power of 2 and 3, 4 and so on. Okay. Next one. See the question here, children. 16 and 64. How we can write? By using the logarithm matrices. We need to use by exponential form. 16 and 64. This we need to represent by what? By using exponential, by using laws of exponents. So 16 means we can write as 2 to the power of 4. 64 means we can write as 2 to the power of 6. 2 power 6, 2 power 5, sir 4. Can I say 2 to the power of 10? Because multiplication, so exponents are added. So 25 we can write as 5 square, 125 we can write as 5 to the power of 3. So 5 power 2, 5 power 3. So we can say 5 to the power of 5. And 128. How we can write, children? 128, 2 to the power of 7. and 32 we can write as a 2 to the power of 5. 2 power 7, 2 power 5. So we can write 2 to the power of 7 minus 5. It is 2 to the power of 2 is the answer. Clear children this answer? Any doubts? Just apply the laws of exponent and find the value. Okay, so that is the final solution. Next one, children, introduction of logarithm. See children, logarithm also is same like exponential form, but it is another way of what writing the number, like expressing the number. Okay, see, I am taking a to the power of x is equal to something n. So I am writing what a power x value is equal to something n. The same representation we can represent by using the logarithm also. So how we can write? We can write as log of this, write down the n here. Here base we can write down here, and this is equal to x. Okay. So it is called what? Logarithm form. The same like exponential form we can convert it as a logarithm form, and logarithm form we can convert as a exponential form. So logarithm form also it is another way of what children? Expressing the bigger number, I can say. See what I am writing. 100 square something n. So how we can write children this? Log of n with base 2 is equal to, with base 10 equal to, so log of 100, so log of n with base 100 is equal to, this is 2. Children, this representation we can call what? Logarithm form. Okay. Children, let us see the one definition. If a and n, so I am taking the both the what? A positive real numbers, and if a is not equal to 1, so how we can write logarithm form? So we can write as log of n with base, with base a is equal to x. Children, here n and x, n, a, x both are what? A positive real numbers. Okay. Here a is called what children? Here base. And the n is called what? Here argument. Okay. And the value of the log n with base x is equal to what? Something x. So this representation is what? The logarithm representation. Just look at children here. Log n with base a, we can write as what? A to the power of x is equal to n. So that is called what? A logarithm form. I'll give another example. And children, remember here base should not be equal to 1. Okay, base cannot be equal to 1 here. 3 to the power of 4 is equal to what? 81. Yes or no? Like 3 into 3 into 3. So how we are representing the logarithm form? It's a very simple. So this is log of, write down here 81. So this base 3 you can write here. This you can write as answer is 4. So log 81 with base 3 is equal to what? Answer is 4. So this is called what? Logarithm form. And it is called what? Exponential form. So this is exponential form and it is a logarithm form. So this is what? Exponential form. And this is what? Logarithm form. Clear children? I'll give another example. 2 to the power of 5 is equal to 32. Tell me children how we can write logarithm form? This write down log of 32. This is called argument. Log of 32. Here base is what? 2. So write down the base is 2 here. Then the exponent is equal to 5. So that is equal to 5 is the answer. So log of 32 with base 2 is equal to what? Answer is 5. So it is what? Exponential form and it is what? A logarithm form. Clear children? Any doubts? The representation of logarithm form and exponential form. It's very simple children. Okay. And I told children here a and n. So both are what? A positive real numbers. We cannot take something real negative children. We take always a positive real number. Okay, that is the first more condition. And one more condition children, here a should not be equal to 1. So the base cannot be equal to 1. Okay, we should not take base is what? Something 1. We can take any value, even non-negative. It should be non-negative 1 and it should be what? A not equal to 1. So then only we can take a is something not equal to 1 value and non-negative value. and here x is what? Something, any real number. Okay, one more thing children, here n is called what? Argument. The value we are writing inside the log. So I am writing here log 5 something with base 3. Here 5 is called what? Argument. And here 3 is called what? Base. Okay, here 5 is called argument and 3 is called what? The base. And here a is the what children? It should be, we can write it as bottom of the log, and it is called what? The base of the logarithm. Okay, this should be written in the bottom of the log, and that is called what? The base of the logarithm. Okay, children, I am writing some examples to try to identify. So log x with base a is equal to capital N. Here what is the argument? Argument means what? The value which will write inside the log. Okay, so I am writing x is what? Inside. So here x is what? Argument. And here a is called what children? He is a base. Okay, and n is called what here? Is a value of the logarithm. We can say n is a value. Clear children? Any doubts? This representation of logarithm. We can write as what? Log x with base a is equal to n. Here x is what? Argument. The value which write the inside the logarithm. Okay, that is called what? Argument. And a is called children here base. And base is always what? A non-negative real number. Like we can say a positive real number children. It is a positive. So this is a positive. And one more thing children, here a should not be equal to 1. So the base cannot be equal to 1. Okay. So these are the condition you have to follow. So whenever you are writing the any logarithm form. Okay. So first remember that argument and base both are real numbers, and base cannot be equal to 1. So these are the what? A primary condition, otherwise a minimum requirements for the logarithm. And children, the log is not defined for the negative values. And the log also not defined when the base is equal to 1. Okay. So these two are very, very important children. It not defined for the negative values, and it is not defined when the base is what? Equal to 1. Clear children? Any doubts? Fine. Next children, look at here how we are converting like exponential form to logarithm form and logarithm form to exponential form. So b to the power of x is equal to a. So how we can write children? It is log of a with base a is equal to x. So it is logarithm form. Next one, see here b is the base and a is the argument. So here this is actually what? The conversion of exponential form to logarithm form. And if I am writing log b a is equal to x, so how we can write children? B to the power of x is equal to a. So this is called what? Logarithm form to exponential form. The first one is what? Exponential to logarithm, and it is logarithm to exponential form. Okay. Next children, look at here, we will do some small questions. So 7 is equal to 2 to the power of x. I want to write in logarithm form. Tell me children, how we can write logarithm form? So 2 to the power of x is equal to 7. Okay. How we can write? We can write as log 7. Here base is what? 2 is the base. So this is equal to x. Okay. Next 10 is equal to 5 to the power of b. So how we can write this? Log 10. So this base 5 write down here is equal to b. So this is log 10 with base 5 is equal to what? B is the answer. Children, it is exponential form and it is a logarithm form. And 1 by 81 is equal to 3 power c. So how we can write children? Log of 1 by 81. Here base is what? 3. So write down here is equal to c. So log of 1 by 81 with base 3 is equal to c is the answer. And this one children, look at here. 100 is equal to 10 power z. So we can write as log of 100 with base is 10 is equal to z is the answer. Okay. So that is the what? Exponential form to logarithm form. And 1 by 257 is equal to what? 4 to the power of a. So how we can write? Log 1 by 257. Here base is what? 4. So write down the 4 and this is exponent a. So it is a what? Exponential to logarithm form. Next one. Children, we need to write the what? A logarithm form to exponential form. So log of 100 with base 10 is equal to 2. So we can write as 100 is equal to 10 to the power of 2. So base is here and the exponent, this value should be written by here. So 100 is equal to what? We can write as 10 to the power of 2. Children, can you tell me this value? We can write as 25 is equal to what? A 5 to the power of 2. Okay? It is logarithm form to exponential form. Children, listen here this example. So log 2 with base 2 is equal to 1. So we can write as 2 is equal to what? A 2 to the power of 1. Yes or no? And next one, x is equal to what? Log 9 with base 2. So we can write as 2 to the power of x is equal to 9. Like 2 to the power of x is equal to 9. So it is what? Again logarithm form to exponential form. Next one. Children, log of 32 with base 2 is equal to x. So we need to find the what is the x value. So log 32 with base 2 is equal to x, children. So how we can write this? We can write as, just remove the, write down the exponential form first of all. It is actually logarithm form, I am writing exponential form. So we can write as 32 is equal to what? A 2 to the power of x. Then 32 is equal to, how we can write 2 to the power of x, children? Sorry, we will do one thing. 32 I am writing as a 2 to the power of 5 and this is what? A 2 to the power of x. Now children, bases are equal. So can I say exponents also equal? So I can say answer is equal to 5 is the answer. The same way. Tell me children this answer. So how we can write this? 625 is equal to, we can write as 5 to the power of y. I am writing first exponential form. And how we can write 625? 625 we can write as a 5 to the power of 4 is equal to 5 to the power of y. Children, bases are same. So we can say exponents also same. So y is equal to 4 is the answer. Okay? Clear children how we are solving? First we are converting into what? Exponential form. Then we are solving the value. Okay? Children, try this sum, the last sum. Log how much? 10,000 with base 10 is equal to z, then find the value of z. Okay children, take this as a practice question. Next one, natural logarithm and common logarithm. Children, what is the natural logarithm and common logarithm? Means very simple children, it is based upon the base value. If the base is e, children, so it is called what? A natural logarithm. Like log 3 with base e. It is called what? A natural logarithm. And children, natural logarithm also we can write as ln 3. The base is e, we can call as natural logarithm. And what is the common logarithm? Common logarithm means the base should be 10 children. The base is 10, we can say that is common logarithm. Children, remember, if they don't mention any base means you can consider the base is 10. Okay. If they are writing something ln 3 means you remember it is what? It is a natural logarithm. So common logarithm means the base is 10 always. You can write one example. I am writing as log 3 with base 10. So it is called what? A common logarithm. Here base is what? 10. Here base is what? E. So here is this is actually what? Example for the natural logarithm, and it is the what? Example for the a common logarithm. Children, look at here. Log e with base is called what? A natural logarithm. The base value should be e. Next one, log 10 with base. Something log with base 10 is called what, children? It is a common logarithm. Here base should be 10. Here base is e and here base is 10. So that is the difference of common logarithm and natural logarithm. Next, children, properties of logarithm. We will see one by one now. First one, what, children? Multiplication. Log of a into b. We can write as what, children? Log a plus log b. And children, remember these formulas we can apply. Otherwise, these laws we can apply only the base value should be same. If the base is same, then only I can apply this formula. It is called what? A product rule. So log a into b. We can write as what, children? Log a plus log b. Okay, that is the first one. We can say it is a product rule. Here addition means, here multiplication means what, children? Here addition. So A into B, log of A into B we can write as log A plus log B. Okay. Next one. Children, what is the next logarithm? Okay, we'll take the example. 35 and 46. I want to apply the what? Log. Log of 35 into 46. And tell me, children, it is a product. Product means what we can do? We can write as addition form. So I am writing log 35 plus I am writing log 46. Okay. Next one, 235. So apply the log 235 into 437. So how we can write, children, it is? We can write as log 235 plus we can write as log 437. So here product means, children, we can write as additional form. Okay. Children, try this sum. Third one. Okay. So both are product, write in addition form. Next one, children, quotient. Here quotient means what? Under division again. So log of m by n. Here division means you have to write subtraction form. So log of m by n we can write as log m minus log n. We'll take one example, children. Log of 23 by 34. Children, both are what? Under division. Under division means we write in subtraction form. So how we can write subtraction form? Log 23 minus log 34. So that is the value. Division means here subtraction. So multiplication means here addition. Okay. Just look at this question. Log 373 divided by 275. Children, it is under division. So division means we can write as subtractional form. So log of 373 minus log of 275. Clear, children? Division means we can write as subtraction form. And children, try these questions. 4325 division 3734 and 5055 divided by 3303. Okay, apply the what? Same again, quotient law. So apply the quotient rule and do the log arithmetic form. Next one, power rule. Here power rule means very simple, children. Log of m to the power of n. So this m will come front. So we can write as n into log with m. N into log m. So it is called what? A power rule. If the argument have any power, so that will be written as in the like before of the log. Suppose if the same, this also we can write as log m with a to the power of b. Here base has an exponent, like base has some power. So at that case we can write as 1 by b log m with base a. Okay. If the argument has exponents, we can write as like exponent will come into numerator place. If the base has the exponent, so we can write into what? Denominator form. So we can write as 1 by b log m with base a. Now children, look at this question and tell me the value. This is what? Log of 7 to the power of 25 with base 2. We can write as 25 into log 7 with base 2. Okay, so 7 has a exponent value, 7 has a exponent. Here 7 is what? Argument. So we can write as 25 into log 7 with base 2. And what about this, children? So this we can write as 50 into log 8 with base 5. Because 50 has the exponent. And what about this, children? Log 5 whole to the power of 3. And what is the base? Here base is what? Something 10. Then how we can write, children? It is 23 into log 5 with base 10. Okay. So 23 into what? Log 5 with base 10. Children, try this sum. Question number 4. Very simple. So 1024 you write as what? 2 power something. So what is the 2 power something? You find out and apply their power law. Clear, children, this question? Are any doubts? Next one, children. Change of base rule. So log A with base B, sorry, log B with base A we can write as log B with base C and log A with base C. Like, I'll give an example. Log 5 with base 2. So this we can write as log 5 by and log 2. Like separating the base. Here base can be anything children, but both the base should be same. If you want to take, you can 3 or you can write here also 3. Okay. And next one is what? It is a chain rule children. Here what? This base is A and here argument also A. Then here both get cancelled. Then answer is equal to what? Log B with base C is the answer. Okay. We can say what children? It is a change of base rule. See children, example. Log 2 with base 3 and log 3 with base 4 and log 4 with base 5. Children, here 3 and 3 get cancelled and 4 and 4 get cancelled. Then what is the answer? Here argument is 2 and base is 5. So answer is equal to what? A log 2 with base 5 is the answer. Here base and argument are getting cancelled. Here base is 3, argument is 3. Here base is 4, argument is 4. So all gets cancelled children. The answer is what? Log 2 with base 5. Next one children, equality rule. It's a very simple. Log A with base B and log C with base B. Okay, then directly we can say A is equal to C. If the bases are same, then we can say arguments are same here. So log A with base B is equal to log C with base B. So we can say A is equal to C. You can see one example children. Log X with base 2 is equal to log 8 with base 2. Children, here bases are equal. Here base is 2, here also base is 2. So directly we can say argument is equal. So X is equal to 8 is the answer. Like this. Okay. Here both the base are same. Here base is 2, here also base is 2. So directly exponents are equal. Sorry, exponents are equal. Arguments are equal. Here X is the argument, even 8 also argument. So I can say X is equal to what? 8 is the answer. Clear children? Okay. Next one. What is this? The number raised to log. It's a very simple children. Here base is B. Here actually what is a B to the power of, how we can write children? B to the power of log X with base B. Here base B and here also base B. So both are equal. Then directly we can write the answer is X. Okay. Here main is the base B and here log, the base of the log also what? Here base B. So here base B and base B both are equal. So directly we can say answer is X is the answer. Okay. Children, look at one example here. See, here base is 2. Even here also base is 2. So what is our answer directly? 5 is the answer. And here also, here base is T. I told you here also base should be 10 only. If they don't mention anything basis means you have to take the basis 10. Here base both are equal. So directly answer is 6. Children, here ln. ln means what? Natural logarithm. So natural logarithm, what is the base? Base should be E. So here main base is E and the base of the log is also E. So both E get cancelled. The answer is equal to 3. Clear children? So any doubts children up to here? So what is the logarithm form and what is the exponential form? And what is the loss of logarithms and loss of exponential form? Children, we will finish one question. Then we can go to the next section in the next class. Children, look at here. Expand the log of what? A 343 by a 125. So 343 and divided by 125. Children, how we can write 343? Tell me children. How we can write 343? So this we can be written as 7 to the power of 3. And 125 we can write as 5 to the power of 3, isn't it? And this I can write as log of 7 by 5 whole to the power of 3. And this we can write as 3 into log 7 by 5. Children, it is under division. Division means what we can do? We can apply the quotient law. So log of 7 by 5 is equal to log 7 minus log 5. Clear children? Any doubts up to here? So in this class we have discussed what is the exponential form and properties of like laws of exponents. Next logarithm form and the questions related to what? Logarithm and laws of logarithms. Okay. So I hope children you understood this complete class. Okay.